Hello, Gators. This is 11-2, Volumes of Prisms and Cylinders, Day 2. I can use the properties of prisms and cylinders to calculate their volumes. Let's take a look at Cavalier's principle. Remember, it says that the volumes of two stacks are the same because the sums of the areas of the cards are the same. If every cross-section is the same and the heights are the same, then your volume has to be the same. Let's take a look at these coins. Every one of the cross-sections of the coins are the same. The heights are all the same. Therefore, the two stacks of coins, whether they stand straight up or oblique, a little irregular, then the volumes will be the same. Let's take a look at this picture. Notice that a right circular cylinder and an oblique circular cylinder are given. The radii of both cylinders are equal. The volumes of the cylinders will be equal because they have the same height. And is this true or is this false? And the answer is it's true. If the cross sections are all the same, which that's what they said, each circle right here has the same radius, so that means the cross section will be the same, and they both have the same height. The volume of a cylinder is equal to the area of the base times the height. Now the base is a circle, so the base will always be the same and we just times it by the height. Let's go ahead and find the volume of these two cylinders. The volume is equal to the area of the base times the height. The area of the base is a circle formula, which is pi r squared h, and then we're going to put 10 in here, and then the height will be 15. Now 10 squared will be 100, so the answer is 150 pi. And then this will be meters cubed. Now this is what we call an exact answer. If we go to the calculator and use the pi button, the answer is going to be 471.2 meters cubed. So again, this is exact and this is a rounded answer. Over here, the volume is equal to the area of the base times the height. It's a circle, so pi r squared h. The radius is not 12, the radius is 6, and the height is 13. So if you take 6 squared, that's 36 times 13, the answer is 468 pi, and that'll be cubic feet. And I'll leave it exact. All right, how many gallons of water does the water cooler bottle contain? So we know that 1 cubic feet is approximately 7.5 gallons. So let's figure out the volume. Volume is area of the base times the height. So this is pi r squared h, and r is going to be 0.5, and then our h is 1.7. And when I take that and multiply it all out, I'm going to use my pi button. I'm going to get the answer 1.335176878. I'm going to figure out how many gallons there are, so the number of gallons will be equal to this number, which is the cubic feet. So I'm going to move that number down here, and I already have it in my calculator. 1.335 ... all of those numbers, and then I'm going to times it by 7.5. Okay, and so I'm going to times that by 7.5, whatever's in my calculator, and I'm going to get approximately 10.0138, and there's more points, there's no more numbers that go, but the best answer out of all offered is this one. So this is about 10 gallons of water. Let's take a look at this sketch and let's revolve it and then find its volume. So if we revolve it going around here, it's going to create a cylinder. So the volume will equal to the area of the base times the height. The area of the base is pi r squared h, and our radius will be 2.5 squared. Height will be 7.4. I'm going to put the whole thing in my calculator. I'll use the pi button. And my answer is approximately 145.3, and this is units cubed. They didn't tell us whether it was feet or inches, so we just used the generic version. Okay, let's do it again. This time we're going to revolve this way, and that's going to create a cylinder that looks like that. So the volume is equal to the area of the base times the height, pi r squared h, and our radius is now 6.1 squared, and our height is 6.8. Putting it in the calculator, I get 794.9, and since they didn't give me the units, I'll just say cubic units. This is where when we're in volume, we're in cubic. Okay, last problem. We want to find the height. So this is a backwards problem. Volume is equal to the area of the base times the height. Volume is equal to pi r squared h. We know the volume, it's 250. And then we have a pi, and we do know the radius, it is 4. And we're looking for the height. So I'm going to try to get the height by itself, I'm going to divide both sides by 16 pi. And then this is 16 pi, because that's what 4 squared is. So all of this will reduce here and reduce here. So h is approximately, now you got to be very careful about putting that in your calculator. Make sure the calculator knows what the denominator is. You might want to use the fraction template. Check it out on your calculator. Just see if you can put this height, get this height, 4.97, and that'll be in feet because the height is in feet.